Okay, so welcome back. This is part 5 in our series where we explain how laptop motherboards work in case you want to learn about them and maybe work on them, repair them. So we're talking about some of the basics of how they work, and in previous videos we've talked about what you see here, which is the input, the DC input to the laptop motherboard. And you can see here we've got the adapter. We talked about these switching MOSFETs that take the 19 volts from the wall outlet AC adapter and send it into the motherboard. And it switches some MOSFETs. It's got a controller here. It measures the input voltage and the current. And it also has what we talked about before, a DC to DC converter that converts the 19 volts to a voltage that you can use to charge the battery. You see, we got a battery here. We also talked about a very, very important part, which is how you get information about the various chips and how you get access to the data sheets for these. It can be kind of complicated. And we also talked about how you can simulate what you see here, this DC to DC converter with a couple MOSFETs, an inductor, and some capacitors. We showed you how to simulate that in LT Spice. Great way to learn. In this video, we're going to focus on a couple things. The first is up here, this adapter that takes the plug from the AC adapter coming from the wall outlet and sends that DC into the laptop. But what you might think is really simple. You might think just, well, I've got a plus 19 volts DC and then a ground, two connections. That's pretty simple, right? Well, as we're going to show, it's a little bit more complicated than that. So it's really important you understand exactly how these are configured. It can vary depending on the manufacturer, the model number, and so on. We're also going to talk about what we talked about in the last video. We're going to go into a little bit more depth about the markings on the integrated circuits and how you can get more information from the data sheets. Really important that you understand that. So let's go to the bench and look at our motherboard and take a look at this input part where we have the DC adapter. So here is the motherboard we've been talking about. Again, I encourage you to get a cheap motherboard like this if you want to learn about laptops and how to repair them. This was a $15 motherboard, HP Pavilion X360. Got it from Walmart. It's got CPU, it's got RAM. Really wonderful deal for only $15. What we're going to talk about in this video is two things. We're first going to focus on this connector here, which is the DC input from the wall adapter that you see here. And it's going to take the 19 volts through this pin and connect the 19 volts through this adapter into the motherboard. And you can see we've got a connector here. And then the motherboard's going to take that 19 volts. And as we talked about before, it's got some DC to DC converters that are going to drop down the voltage to different levels and spread it throughout the motherboard. We're also in this video going to talk a little bit about the integrated circuits and getting data from the data sheets, and there's a lot of good information on the data sheets we're going to talk about. But we're going to start out with this connector. This did not come with the motherboard. I spent a few dollars to buy this on eBay, and as you can see, we've got the connector, which is a female, and here is the male coming from the adapter. The adapter is plugged in. I'm just going to plug this in and we can see what happens. After a few seconds, you can see a green light goes on. So if you're thinking about this off the top of your head, you might think, well, all it does is it takes 19 volts plus and minus coming into the motherboard. Why does it have all these wires on this connector? It's got a bunch of pins. Why do we need that? All it needs is 19 volts, right? Well, as you can see, we've got an LED here. So what the laptop did, what the motherboard did, is it sensed this adapter with 19 volts, and it did some logic in here, which means when you plug this in, there's some logic going on, which means you've got some voltage being supplied even without turning it on. And there's some logic going on here that said, hey, I just sensed an adapter. I'm going to send a signal and turn on this LED so that it shows a green light. There's also some logic that will change the color of this light depending on whether you're charging the battery and so on. But you can start to see why there are more pins than you'd expect. So what we're going to talk about in this video is we're going to talk about the details of how this is configured how these connectors are configured, a little bit more complicated than you might think. And then we're going to get into the data sheets for these integrated circuits. So here is an exploded view of what we saw on the bench. Here's our AC adapter that's feeding 19 volts. Here is the HP plug, and you can see it's got the HP blue ring, and you can see it's a metal cylinder, and it's got a pin, and it's also got another cylinder on the inside. So here's an exploded view of it. We've got on the outside a metal cylinder, which is the ground. On the inside, we have another metal cylinder, which is not connected to that or anything else, and that's the 19 volts. We also have a third metal connector, which is this pin, and that is a sense pin. And that is used to sense when the adapter is plugged in and some properties of the adapter to make sure it's the right adapter. So there's three things that are being measured here using these three connectors. So what you might think is really pretty straightforward gets to be kind of complicated. And here is our male plug, and here is the back of the female connector that's on the laptop. And as we said before, we've got the ground, we've got plus 19 volts and a sense pin. The ground is going to be a black wire, the plus 19 is usually a red wire, and the sense pin is going to be a green wire. And if you look here on the back, you can see we've got a red wire, we've got a green wire that goes to the sense pin, and we've got a black wire, you can barely see it, that goes to this outside cylinder. So these are the three power and sense pins, but we've also got two more wires here. And as you can imagine, as we showed before, there is an LED in here that goes on and changes color depending on the state. So we've got these two wires for the LED. So now you can see why we've got multiple wires in this connector. So again, here is our female connector, and you can see it's got the pin goes in here. Then we've got an internal cylinder and then an external cylinder, and we've got an LED. And that's why we have all these wires coming out of this, because on the right you can see we've got two red wires, which are the two plus 19 volts, and there's two wires to allow it to carry more current. We've got two black wires, which is the ground, which again, two wires to allow it to carry more current. We've got an empty place in this connector, and then we've got a green, a yellow, and white. So as we said, the green is this sense pin, and then the white and the yellow are used to turn on and off the LED and also to have it change color. So now you can understand, if you see your input connector from the DC adapter has got a lot of wires to it, you can start to understand, hey, there's a lot more going on, so I need to look at that and figure out what these are so I can understand what's going on. So now, to get a better understanding of that light, the LED on the female receptacle for the AC adapter, one way is you could look at the owner's manual for the laptop that this came from, where this motherboard came from. It's an HP Pavilion X360. If you scroll down to the section where the AC adapter is described, and you zoom in, you can see AC adapter and battery light. It's white when the AC adapter is connected and the battery is fully charged. It's blinking white when the AC adapter is disconnected and the battery has reached a low battery level. It's amber when the AC adapter is connected and the battery is charging, or it's off if the battery is not charging. Now in our case, we don't even have a battery. And when we plug it in, after a few seconds, it becomes amber. So then you can start thinking about, this says the AC adapter is connected, the battery is charging. In order for this to happen, these different colors, you're going to have to think about, well, how does it change from white to blinking white to amber? So it's going to have to sense the adapter. If it's connected or disconnected, it's going to have to check the battery if it's got a low battery level. So you can start to think about how this is being implemented and how are you changing colors of the LED and so on. So this is another great opportunity. You can start measuring with your multimeter the white and yellow wires to see what the voltages to the LED are, and you can start thinking about how this can be implemented based on what we showed before, where we're measuring the DC coming from the AC adapter. We've got that voltage divider, we've got the current sensor, and so on. So this is one other area you can start thinking about. Again, it's really important that you look at these sources of data, like the service manual for the laptop it came from, and also the data sheets for different components and the power management chip and so on. It's a great way to learn. Okay, so now that we have a pretty good idea of what's going on with this female input jack receptacle and the LED, let's go down to the motherboard where this connector comes into and see if we can figure out what's going on, and if it's as we expect, the connections are going into the motherboard and the components we expect are there. And as we said before, we expect coming from the adapter, there might be a couple of MOSFETs to switch this on and off, maybe a current sensing resistor, some resistors for adapter detection, and some other stuff. So let's go take a look at the motherboard and see what we have. So here is a photograph of the input connector from the DC jack. And as you can see, here's the connector, and as we expected, there's two red wires coming from the plus, from the cylinders in the DC jack, two black wires for the ground, and again we have two wires to give us more current carrying capability. Then we have a blank, and then we have a green wire from the sense pin, we have a yellow wire and a white wire from the LED on the DC jack input. And here is all the components that are associated with this DC input. So let's see if we can figure out what's going on. Well, as we expect, the two pins for the plus 19 volts are tied together with a large trace to give us more current carrying capability. In our case, it's going to be maybe 3 amps or so. And what we expect is that there should be a couple MOSFETs, as we showed. And if you go right here, you can see, well, there they are, two MOSFETs. If you recognize this logo, it's the Alpha and Omega company, and it's a 7403, and here's the identical upside down, but you can see we've got these two MOSFETs, and here is a high current, you can see it's a wide trace, current sense resistor of 10 milliohms, R010, and you can see that that pretty much matches what we expect. We got the switching MOSFETs and the current sense resistor. Now let's take a look at these 7403 MOSFETs and see if they're what we expect. As we said before, we don't have the data sheet for the BQ24737, but we have it for the 735. And so we're expecting these MOSFETs to be in-channel MOSFETs. You can see this arrow pointing in. So we can take a look at the actual MOSFETs and see if they match. Well, here is the data sheet for the Alpha and Omega AON7403. And these are 30 volt P-channel MOSFETs. And if you can look here, you can see, well, it's not what we expected. The arrow's pointing out, which means it's a P-channel, which means in order to turn it on, you need to apply a negative voltage between gate and source. And you can see it's still an 8-pin device. And if you look down here, you can see that the parameters are that the VGS threshold, the amount of voltage required between gate and source to turn it on, is minimum of about 1.7, minus 1.7 or minus 2.2. So this is saying you need a negative voltage to turn it on. And from our diagram for the 735, it's an N channel, which means a positive voltage to turn it on. So again, this BQ24735 doesn't exactly match our 737. So we have to be very careful if we don't have the exact data sheet for our device. So now it's really important that if we're going to reverse engineer something, as we've shown, it's nice to have an expectation about what should be there rather than just going in blindly and seeing what's there and accepting it. You have to prepare for it. That's a much better way to reverse engineer something. So we pretty much got this matching what we expected. To some extent, of course, the device is a little bit different. We've also got a lot of these devices over here that look the same. And they're 3-pin devices. And you may expect that they're probably MOSFETs. And we've got some markings that are about the same on these. We've got a K72N7, K72N7, K27K1, K27, K1, and then we've got a K72N7, K72N7, and some others. So we can imagine that these are probably MOSFETs that are doing some switching associated with the sense pin and also the LED. So what we can do is we can look up what are these K72 devices. Again, this code on top of the device isn't necessarily the catalog number. It could be just a code that you have to reverse engineer and figure out what's the actual device. So after a little bit of research, I found a Diodes Incorporated in-channel enhancement mode MOSFET, a 2N7002. And if you look on this for the marking information, it says, yes, it's a K72, and then it's got a year and a month on it. So this is probably what we have. You can look around and see others. But basically, this is saying it's an N-channel, single N-channel MOSFET where the drain is on the top, the gate is on the left, and the source is on the bottom. So if we look at these, we can see K72, we've got a drain and a source and the gate here, the drain and the source and the gate here, and there's probably something similar for the K27. But of course, this is a 6-pin package where these are individual MOSFETs with a 3-pin package. So now a while back I did a series on desktop ATX power supplies, and we got into detail about what comes into your, in this case your laptop, your power adapter from the power company. We talked about the power company, how it's configured, and some of the protective devices on the power company side of your wall outlet. And we also talked about how sometimes you can get large power spikes from, for example, lightning storms and that kind of thing that might get through your adapter or your ATX power supply and might cause some problems. So often this area where the 19 volts comes in from your adapter might be more susceptible to power spikes and problems from either inside your home or office or from the power company. So one of the more common failure areas might be here where you've got your MOSFETs. But if you look here, you can see the 19 volt plus. You've got a lot of devices connected to it aside from this first MOSFET. You've got these capacitors where all of these are connected directly. You've got the MOSFET, of course, and you've also got this device. And you can see the gate is tied directly to this 19 volts. So there's a lot of areas for failure. If you should get a spike of voltage coming in here, there's a lot of components that might fail. So just keep that in mind. It's really important that you look at in your photograph of your circuit what's connected together, and also use the continuity checker on your multimeter to verify what's connected together, so you can be aware that if something happens, these might be susceptible to having problems. Okay, so that's it for this one. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.